Welcome to Permacem 2.0, the new self-adhesive cement from DMG. And when I talk about this, I naturally would like to explain a little bit about cements first, then go into adhesion, and finally let you know what makes up Permacem 2.0. So let's start. What do we need cements for? Basically, any so-called indirect restoration, anything that comes from the lab that is not done by the dentist. So all the crowns, bridges, inlays, onlays, and veneers, the typical stuff. And they can come in a variety of materials. Noble metals, non-precious metals, ceramics, various ceramics in fact, and all of these require different luting and cementing. Now, when we want to group cements, we can basically have two very large groups. Group number one is the retentive cements. And to illustrate this, I brought these two strips of abrasive paper. And if I put these two strips of abrasive paper together and I try to move them, they don't move because they interlock. But even though the interlocking, the friction part is good, adhesion is zero. So this is the other part, the interesting part, and that is adhesive cements. And to show you this, I put a little bit of water on one of these slides here and put another slide on top of it. And you can actually really, this is why they're called slides, you can slide them against each other so there is no friction. But if you try to pull them apart, they really stick together very, very well. So no friction, but a lot of adhesion. And in a composite cement, for example, and especially a self-adhesive cement, you find both functions. You have both retentive elements and adhesive elements. But when you're thinking about cements in general, the first thing that usually comes to mind is the cement you use to build your house, to put together the bricks. And the reaction that is happening in this cement is actually really the same as in some very old and reliable cements, phosphate cement, for example. So in these, what you have is glass particles. And these glass particles are in an acidic matrix. And that acid reacts with this glass particle, so in an acid-base reaction. And the result of this is that, first of all, the surface gets sort of diluted, and then you build a salt out of this. Salt not in the sense of table salt, which is very soluble in water, but salt in the sense of a compound like gypsum, for example. And these crystals that are formed in this salt, they can interlock with any surface, and they will interlock with each other. And this interlocking is the basic curing and setting reaction of the cement. And even though this may seem a bit crude, like in this example, micromechanical interlocking is quite a strong force and can hold things really well together. But it also works on a lower level, like when we etch enamel and we put a bonding agent on this etched surface, then these cured resin parts interlock with this surface, and this is quite a strong bond. So micromechanical interlocking is also a driving force in cements. And to show you this a little bit, let me explain a bit more about Permacem, the predecessor. So Permacem is already a resin cement, which means it has higher initial strength and it's more aesthetic. But to try out what's it about adhesion, we created the same type of crown fitting. So same length for the abutment, same surface, and that wasn't easy, but we did it and we put crowns on top of it. And we cemented the crowns first of all with Harvard cement, then with Permacem without a bonding agent, in this case without contacts, and in the last case Permacem with contacts. And the results were quite striking and stunning. First of all, even without a bonding agent, Permacem had 3 times as much adhesion to the two-structure as did Harvard cement. And the second part, You could even double this figure by using a bonding agent. So this sounds good, but for a lot of dentists it was also very frustrating because they wanted always to know, do I need a bonding agent or don't I, and when? And this is now all over because with Permacem 2.0 you don't need any bonding agent. And this is what really got dentists to it. If you look at this graph, you can see that the zinc phosphate, adhesive, whatever cement, they basically stay level. The only material group that goes against this trend is self-adhesion. And the reason for this is very obvious, because it's so easy. And because we have a shift towards cementing full ceramics. By now, we have about a 50-50 distribution between metal-based restoration and ceramics. But this trend towards more ceramics is going to continue, and we're going to see more of it. And that means we need more resin cements. And ideally, we need a self-adhesive cement because we don't want to bother about bonding these. So, in the next part, therefore, let's talk about adhesion. Thank you.